Okay, in this video I'll be talking about frequency distributions. It says a frequency distribution is a listing of the observed values of an experiment and the corresponding frequency or occurrence of each value. So basically you're collecting data here, and notice here this is in a class of 30 students. Each student was surveyed to see how many units or credit hours they were taking. The results are as follows. So basically the frequency is just how many times each piece of data occurs. So in this problem here, for example, the 12 would be what we call a piece of data. It's one of my values. And notice down here it says to create a frequency distribution for the data should first be put in order. And so I've done that, and now it's easy to see how frequently each data value occurs, or each piece of data occurs. So for example, the frequency of 15 is 2, since there are 2 occurrences of that data value. Alright, so next it says notice that the observed values range from 3 to 18. So now what we're trying to do is we want to create a visual, or basically a chart really, to organize our data. And these are what we call frequency distributions. Now it says there's 2 possible frequency distributions for this data. If you look at the one on the left, it says number of units or credit hours. These are our observed values. So we observed 3s, 4s, all the way up to 18 units. And then you can see how frequently each value occurred. So for example, here you had 3 credit hours, and there were 3 people or 3 students that had that number of units. Notice if you add all of the frequencies, that should add up to 30, which is the number of students that were polled. Now, the table over to the right here is what we call a grouped frequency distribution, and I would prefer one in a problem like this. I would probably prefer this variation. Notice in this case we have classes. So 3 to 5 is a class, and in fact there's 6 classes here, and one of the things you should notice about each class is they have what's called the same width, which would be 3. In other words, each class has 3 numbers in it: 3, 4, 5, 6, 7, 8, and so on. So that's what we call the class width. So again, there's 6 classes. Each one has a width of 3. Let's look at this class here. That includes the numbers 9 through 11, which stands for number of credit hours. So we would call the 9 the lower limit for that class, and the 11 would be what we call the upper limit for that class. Notice here it says data is often grouped in classes to make the information easier to interpret. The rules for data grouped by classes include the following. Number 1, the classes should be of the same width. In ours, each class had a width of 3. The classes should not overlap, and each piece of data should belong to only one class. Sometimes one of the classes may be a little bit bigger just to make an adjustment for the numbers, but normally they're all going to be the same size. Notice also it recommends 5 to 12 classes when you make a frequency distribution. And by the way, these frequency distributions, we end up doing some kind of bar graph or other visual type of graph to represent this data. But we're not doing that yet. Let's go ahead to the next slide here. And so based on what we just discussed, I'd like you to look at this frequency distribution table. Notice it's a grouped frequency distribution for math test scores. And then go ahead and answer the questions in this problem number 1. All right, so it says, first of all, well, we're supposed to determine the following. Letter A, it says the total number of observations. Well, we're going to want to add up our frequencies, and you should have gotten 25 there. And so there were a total of 25 students in this class, or students that were polled in some math class. The width of each class, well, be careful here. The first class goes from 40 to 49. If you count each number, there's actually 10 there. It's not 9, so be careful. You can actually count them out. 40, 41, 42, 43, all the way up to 49. There are 10. And then the lower class limit for the first class, well, this is the first class, so the lower limit would be the 40. The upper class limit for the last class, well, that would be this class, and that would be 99. Now, there's another type of basically like a little chart to organize our data, and it's called the stem and leaf plot. And so I'm going to go ahead and show you how that works with this data we have here for car speeds. So basically, I'm guessing that there's some lady perhaps in a neighborhood, and she lives in this neighborhood, and people are racing through the neighborhood. And so maybe she was able to talk to a policeman, and somehow she got a speed gun, or I don't know, maybe you can buy one of those these days without too much trouble, without too much cost. So she's checking the speeds on these cards, and then she's going to let people know, let the government know how fast people are going in her neighborhood. So we're going to go ahead and put together a stem and leaf plot. So you start by setting it up like this. So the stem is going to be, let's see, it'll, in this case, notice each of these numbers has a number in the tens place and also in the ones place. The leaf always just has the last digit, or the ones in these numbers, and the stem will have the other digits. So in this case, we're just going to put the 10 digit in the stem column. So I'm going to go through the first column here, the first row. And by the way, you can see that our values range from the 30s all the way to the 70s. So when we do our stem, we're going to start with 3. And so these are our numbers that are in the 30s. And again, I'll start in the first row here. And you can see we've got the 35. So I'm going to cross that off. And let's see, we'll put the 5 in the leaf column, which is our 1. So again, the stem in this case has our tens place, and the leaf has our ones. So let's go to the next column, look for some 30s. You can see 32, so we'll go ahead and add a, oops, I hit the wrong button there. And so, hold on just a second. We got the 32, so we'll add a 2 here. And then the 36, so we'll put a 6 in here. So that takes care of the second row. Then we've got a 32 in the third row. In the last row, we have a couple of 35s. And so we'll put 2 5s here. And then now we'll go to the 40s. So looking in the first row, we've got 42. So we need to put a 2 here. We got a couple of 40s. So we'll put a 0 in here for each one of those. In the second row, we've got a 40. Seems to be a popular speed. And let's see, in the third row, we got 45, 43, and another 45. And then let's see, in the last one we have 40 and 48. Notice I'm crossing these off as we go. So now let's go to our 50s. And so in the first row we have a 50, so I need a 0 there. In the second row we have 2 50s, so we need 2 zeros there. And it looks like that's all of our 50s. Let's go to 60. Notice there's just one number in the 60s, that's 61. And in the 70s, we have one number, that would be 70. Boy, that's awfully quick. I don't know what the speed limit is, but that's probably way over the speed limit there. All right, so this is a correct answer, but we normally put these digits on the right side in order. And so now I can show you the final answer here, which looks like that. All right, and that's it for this video.